Here we go. Okay, so this tutorial, we will see how I think the most important part to understand, the most important thing to understand from this tutorial is how what the new organization of the CROCO code, what is calling here the framework, is a bit different from the code structure we saw last week. So we just had the 1.2 version now. So the code is in a different in different folders, but let's try to learn that. And this is made so it can be more automatic the way we do coupling, for example. So to get this code, we follow this instruction, the installation. And well, the coupling that we will do here is with this more or less the Benguela domain, the same area. So we will compile the CROCO code for that. We have a code for wave watch, for wave model, and WRF for the atmospheric model. But these are already defined. These were created before. So how to create a new domain, how to create the grids, that's another stage. So, okay, let me increase the size of this. So I have my directory empty. So the first thing I do is I create a directory. Then I will copy this file. Here, I want to edit file. And let's see. So I need to make sure that this machine has it says Leftraru, because there are some configuration specific to this computer center. You have to make sure that this crocodile points to this direction where you have the last version of the code obtained from the GitLab site, and the CROCO tools direction is here. Then you have to define this configuration, and in this case, what we call Beng, as short for Benguela. So all this, you have to make sure that these directories are defined as this, pwd. And here I'm going to select what I want to install, and here I activate this. All production coupling. Okay, so I write this and I exit. I run this. It will ask me if this is what I want. I say yes. Everything is okay. So now I have my directory Beng with many files. So this is this part. Now I have to copy another file. Is this file? Create useful links. I copy this here. Then I run this and give you many warnings. Don't pay attention to that. It's trying to copy or create a link for a file that is already there. But what that did was to create put a lot of information here. Your upper directory. Before you only had this config directory where we were working. Now we have all these other directories with some information. Okay, so now let's go to this case. First, we are going to source this script to add some paths and environmental variables. Okay, nothing happens. Well, nothing should show up. So that's in any new system, in any new computer, that's an important file. Is to find the many variables. The next important file is this myjob.sh. Here in this line is going to say to the machine, this HPC center, that this job is only going to run for half an hour. That's very useful because the computing system will give priority to runs that are short in time so they can process. That way you don't have to wait a lot of time until your job starts calculating. So this is something relative to supercomputer centers. This is the year and the month and the day we're going to do a simulation. We want to, here's defined as, let's run for 1 month. Just to make things more fast, let's just run 2 days. 2 days just once. This is not a restart, is we're starting from an input file. So the main changes was just to change how long was this run, 2 days. We write this, okay. This part. So now we will edit one of the key files, one of the most important files for this. My name is .sh. First, I want to give a name to this experiment. It will be Benguela experiment 1, but I will also make some clarification. This will be a run only with CROCO, no coupling, no waves, no atmospheric model, just in some way the normal CROCO run. And we name this kind of runs forced runs. So we don't want to use an atmospheric model. We want to use an oceanic model. We don't want to use a wave model. Only the ocean. We don't have to change anything here. And here, this is an important line. This means that once we submit the job, the job itself will take care of compiling the CROCO executable. It's not that we have to do job comp before sending our simulation. We send the simulation, CROCO is being compiled, and then CROCO runs. So it's the compilation is included in the submission. Well, there are many things here, but let's here. This is important. If we don't have, if we're not coupling with an atmospheric model, we have to have this as a true. That means we are supplying the surface forcing. We want to do a interpolation online. That is the surface forcing is interpolated to the grid of the model during the run. And we will feed this with CFSR data outputs. And that's it. That's the main changes we have to do. This is not a couple run. We exit. And to launch simulation, we use this another script, submit job. Okay, so let's see how it goes.
Andrés?
Yes.
You use the same folder that we were using the day before, yesterday?
No.
Copy.
Everything is new.
Okay, so you make a fresh start of the original folder of CROCO.
Yeah, this is the new 1.2 version that just came up. So everything that we learned last week is old stuff.
No, yes, but the folder, because in the path you set the CROCO folder, but it's the same one that we used yesterday for the
No. It's one CROCO folder that is in the account instructor one that has the new code.
Okay.
Last week you were using a different version.
Can you share that?
Sorry?
Can you share that code to copy the new version because I think there is not in the tutorial.
Yeah, it's on the tutorial. You will copy it in the tutorial. With this script, we will having a copy of the code.
Ah, okay, I didn't see.
So don't worry. Everything is included.
Okay, thank you.
Hi, Andrés.
Yes, Frederic.
Yeah, the crocodile in the script. In the script, we have to change instructor 01 to our username, or we have to leave it like that.
Leave it like that. You don't have to
okay.
only make the changes that you see here. This you leave this is automatically.
Yes. So
here is very automated, so you don't have to change many of the paths. It's a new CROCO.
Okay.
So let me show you that works. So you could see that a batch was submitted. It should have finished already. So let me see. Oh no, it's running there because it's compiling. So this takes like 5 minutes. So you can see that the new directories that were created at this. And if you want to see the process, how is it going, you can do tail -f jobs. Oh, already seems to be is already finished. Let's see. Yeah, already finished. So I will show you later. So the new files, the new directories are these. You have CROCO in that has many files, and notice this is the executable, and this is the FRC that we define as a name. So it's an executable for forced runs, not coupled runs. So this is the CROCO code. And all the results will be in this run dir. So we have one directory for the outputs from the model and one directory for the results. So if I want to see the outputs, there's another directory. Here I can see the history file and the average file. And if I want to see the restarts, I see here the restart. So only the classical history restart, history average file from CROCO. And the other one is execute. Here I have the files that were used to run the simulation, and you can see that precipitation rate was from this file. So we didn't do a make forcing in this case. Everything was done online. So this worked. We finished this. Now this is a simple simulation. Let's copy our nameless file to nameless forcing, just for reference. And this is important. We have to edit the file my job because it was updated. So we will do the same type thing, but for now coupling with other models. So we will start the same day. We will run this 2 days. We want just one job, and this was false. So it's same as before. Okay. This is.
Andrés,
Yes.
I think there's a typo with the false.
Yeah.
Oh. Thank you. Thank you. Thank you very much.
You're welcome.
Yeah, so I will add what the new version, but you have to go to the back to the old version. I will extend the tutorial. So now let's do a run coupling CROCO and WaveWatch. How do we do that? Well, here's what I just did. We work with this my nameless file. I will call this experiment 2, where I do ocean and waves. My executable, I want to be named ocean waves. And here I activate the wave model. What else is here? I keep, well, the coupling frequency between the models, and we can look at this later in the NAM couple file, is every hour. So the models are exchanging information every hour. I still want to the completions to happen online. So right now I don't have an executable file from CROCO that considers coupling, but it will exist. I keep this as a true because I still don't have an atmospheric model, so I will still use CFSR as my forcing, so this stays the same. And this is not atmosphere. Now go to the wave model. And here I have to tell the model this. I have to tell the wave model. The wave model needs also forcing. I'm telling the model that CFSR win, the file CFSR win will be forcing this model. And this becomes, there's an intermediate file that will be called win.nc. So that is read by the PRNC input. So if you know wave watch, you know what this means. If you don't know wave watch, and you want to couple with model with CROCO, you need to learn wave watch. So this is the complex part of coupling, that you need to learn more models. So, okay, this is everything. I save and exit, and I send my job in the same way. So now I can do tail minus F job for a second experiment. And this .out file that in the last week we were looking at the slurm.out files. These are the new out files. And we can look meanwhile how this is advancing. It will take at least 3 to 4 minutes just to compile CROCO. Remember, CROCO is not compiled, but here we can see that is understanding that is coupling with a wave model. Let me see if there are some questions I can answer meanwhile. Okay, yeah, you can delete the directory. It's.
I have a question. I don't know if
Yes.
I'm confused, but so now we compile and run together. Oh.
You can do that if you define in the my namelist.sh, if you set this, it means there's no executable, compile, modify the CPP defs and then compile. This is what I understand. Of course, if you're doing many runs, maybe you don't need to compile every time, and you can compile for the first month, and then the next 20 months you just use the same.
So I can change there. I can put 0, and so just run, right?
In theory, yes. Yes, but that's the idea. Either you compile online or you have already the executable in the correct place with the right name. So this is running still. In this case, I'm not sure where, well, they were, maybe we can talk about later how you define how many nodes or where you specify that. But here is using 5 nodes. I think it should be like over here. Okay, you can see here that the model is running already. My job, in this case, I think in my job I saw something for the how many CPUs used in each case. So we do compile the CROCO, but we don't compile the WaveWatch. WaveWatch is already compiled for this case. And I think this is what is actually is launching the model. Okay, this is finished. So again, if we check the run there, we can see that we have the execute, output, and restart from the first experiment, that the first experiment, the execute, the outputs from the ocean wave couplet, the second experiment. If we look at this experiment, we see the outputs. We will see that we have his an average file for CROCO, but also we have the an output file for WaveWatch. So WaveWatch is calculating also. There's wave current interaction, and we have the output file and the output grid and the grid from WaveWatch. So we have more outputs because now we have results from 2 models that are connected. And we have restarts for WaveWatch and also the restart for CROCO. So that is one couple run. And we are here, yeah, it's got the number 2, number 3. We did this. So now let's again copy my name list to my name list, but in this case, ocean wave. Okay, so far so good.
Yes, Andres.
Yes.
Are we going to view the outputs after?
Yes. Yes.
Okay. Thanks.
Camila.
Oh yeah. Yes. Sorry, I am.
So now let's couple CROCO with WRF. So you can see the idea is more or less the same. First, let's make sure that we don't have a mistake here, because we want to run the same period, 2 days. This is 1, and this is okay. And again, my name list. So now I call this experiment 3, ocean atmosphere. Ocean atmosphere. For the executable, I will use an atmospheric model, oceanic model, and no wave model. Okay, same here. We still compile online. Here, atmosphere, since it was better to change this to the time step to 100. Here. Since now we have an atmospheric model, we don't need surface forcing. And since we don't use surface forcing, we don't worry about this. So we have to change this. Let's see. Okay, we're here. So we save, we exit, we send the job. Number 3. Tail minus F, job number 3. Angela put out. And now it shows that it's coupling with an atmospheric model. That is, as was mentioned, WRF 0.431 with some modifications. Let me look at the questions meanwhile. Okay, it's David is asking about the computational cost. And yes, you have 2 models, so you have more than twice the amount, and you have to also consider the cost for OASIS. So I think here's where you define the numbers of cores for each option. So how much will be? Well, it will depend a lot on your problem. So, as they say, the ocean model has 4 cores, and the wave model, the atmosphere, 12, 14 for the wave model. So you can change this, and of course, you need to do a scaling study to see. Also, if you want to look at a different thing about that, the exchange coupling frequency is 1 hour, but the ocean model, you're calculating every 600 seconds, but the atmospheric model is each 100 seconds. So the time step is 5 times more slow in the atmospheric model. So as I mentioned, now you need to become expert in CROCO, in Waywatch, in WRF, and in Oasis. But I want to show this. Hundir, Andrés, yeah. So in this directory that has the executable files for the experiment 3, that's ocean atmosphere coupling, you have this num couple file. That is one of the key files for Oasis. So this is running already. So this is a kind of call to run that means I'm launching several executable files at the same time. So because there's one executable file for the CROCO, for WRF, for the coupler, and you can have more. And so these are the executable files that are being used in this case. So aim to understand this file, this num couple file, because that's how the coupling is done in this case. This is experiment 3. And when we're doing this, and when this finishes, we will see the execute outputs and restart directories for this experiment. And in the outputs, we will see output for CROCO and for WRF. We see the WRF out standard file. And this is a new one that has allows you to have an average. It's like an average file for WRF. So well, I don't think it's thanks to me. I think thanks to Sven for all the, and Matthew and Jill does all the work that I'm just demonstrating something that they built. So it's not my development. Okay, this is done. Run there. Now we have 3 directories for the 3 experiments. And like I was saying, experiment 3 outputs. These are the output files for CROCO and for WRF. Yes. And you have the restart files for WRF and CROCO and many other things. Okay, so okay, don't remember my name list to my name list dot ocean atmosphere. That was this case. And let's do the final, like they say, the full 9 yards CROCO, Waywatch, and WRF. So we do again, now my job. To do this in the same period, 2 days, 1 false, okay. And now I want to do my name list. This is the most important file where I use atmosphere, ocean, and now I use wave model. Again, we check the usual stuff. Coupling frequency, 1 hour, online compilation, yes. With surface flag false because we have an atmospheric model, so that's fine. Atmosphere 100, and here there's something else to change. This is something related to the surface fluxes that you have to set as 5 when you're coupling wave. And since we now have an atmospheric model, we don't need to put CFSR winds in the wave model because the wave WRF will give winds to the wave model also and to the ocean model. So we put this as empty. And this is it. Well, exit now.
Andrés, I think you forgot to change the run type because you're having ocean wave atmosphere.
Yes, thank you. This, the most, and here I have to change the run type for the executable and the experiment name. Thank you. Yeah. See? So it's running, tail minus F. And 4. So you can see that this run is coupled with atmosphere and with wave. And we will see the results. This takes some time, but the outputs, the results will be this average and his file for CROCO, the Waywatch grid here, and the WRF out for WRF, and many restart files. And you can save it with one name just to compare the difference. And I put these files here, just you can download them to check them. And later I will put output files there so you can compare. So yes, we're using more models, more expensive models. So be ready to spend much more time on this, much more computer time. So I guess to analyze the results, my recommendation is to use NCDIF. So you can copy, for example, from, where's it? From the experiment 1 output, for example, the average file to CROCO for set.nc is not a good name for, it puts O for ocean only. Then copy run deer Minghella experiment 1, no, experiment 2 with wave outputs CROCO average. You can copy to CROCO. Okay, ocean wave. And you can copy run deer Minghella experiment 3. CROCO on MVG ocean atmosphere. I made a mistake aquí. Let me move. Scrum time. Wow. So just now the code is running. Yeah? This is only now the couple model is only now is running. But what I was trying to show is that these are three files from the same period, and then as we saw in the previous weeks, you can use ncdiff. Maybe you can run nco. No, we haven't. Where is that tutorial? To use NCO, you can do this. So then now you can use ncdiff to say, let's calculate CROCO atmospheric minus CROCO only ocean. And we call this ocean minus o.nc. And then we can use NCView. What is
It's wrong in imp/2019. You put 2091.
Oh, sorry. Here. Yeah, so in CView, oh, this will give me the difference between the fields for, I don't know, say surface temperature. This is the bottom layer. So, well, these are the difference between the two models, because one was forced using CFSR and the other one was forced WRF with CFSR as boundaries. So, well, this finished. So run there. Now we have experiments, results from the experiment 4. Experiment 4 output. We have output for CROCO, for WRF, for Waywatch. Let's copy my name list this to my name list ocean wave atmosphere. And you can start exploring the difference between the two, how they change in time, the range of values. Well, anyways. And the last, no, this is not. So conclusions, you follow these steps. I hope you can get all the results and you can do your first couple run, or not the first one. Here are the tutorials that are very good for to increase your knowledge in all the details for. So the material that is on the web from the CROCO group is very, very, very good. So take a look at this to learn a lot more. And what I wanted to show is one of the extras in this is how to get for those who work with the old code, how to get the old code. If you want your 1.2 in the new classic, what you need to do is to say here all depth and then when you run this, so you go to Benguela Classic. You will have more or less what we were using last week. Okay, so I will stop the